Hello mathematicians. Today we see one more interesting problem asked in CSIR June. It is a limit problem from real analysis. So let's review the question. So let p of x be a polynomial in the real variable x of degree 5. So it is given that it degree 5, but our argument will show that even if it is of degree k, the answer is still going to be same. Okay, so what we want to find? We want to find limit n tend to infinity p of n by 2 power n. Okay, one general understanding is so this is called exponentials 2 power n. Numerator is polynomial. So the one general our understanding is exponentials dominates polynomial. So this you can remember as a mantra. So always exponential dominates polynomials. Therefore, once there is exponential in the denominator, polynomial in the numerator, this exponential will dominate the numerator. So yeah, denominator dominates means denominator goes to infinity very fast than the numerator. That's what we mean by dominates. Therefore, once the denominator goes to infinity fast, the answer is 0. Okay, so that is our observation. So that is roughly the argument. So but again we can rigorously give the proof. Now as I said, p of n is a polynomial of degree 5, but the argument we going to give work for any degree. For simplicity we do it again just for 5. So we take p of x equal to a naught plus a1 x plus a2 x square plus a3 x cube plus a4 x power 4 plus a5 x power 5. I take a polynomial of degree 5. Now we want to calculate uh, p of n by 2 power n. So we calculate what is p of n by 2 power n. This is a naught plus a1 times n. In place of x we have to substitute n plus a2 n square plus a3 n cube plus a power 4 n power 4 plus a power 5 n power 5 whole divided by 2 power n. Okay, now we'll look at the sequence. Now we see what is limit n tend to infinity some n power k by 2 power n. Okay, so k is some arbitrary positive integer. We can take it to be any number, doesn't matter. So what is the value of this limit n tend to infinity n power k by 2 power n? Okay, so one can directly prove that this limit is actually equal to 0. One way of seeing it as this limit is of the form infinity by infinity. You substitute n tend to infinity in the numerator, you get n power, that is infinity. Denominator also as n tend to infinity, we get infinity. 2 power n tends to infinity. So it is of the form infinity by infinity. So what we need to do, we have to differentiate with respect to n. Okay, then by L'Hospital rule, this limit is equal to k times n power k minus 1 divided by, you have to differentiate the 2 power n. What is the differentiation of 2 power n with respect to n? If you differentiate 2 power n, you will get 2 power n, but we do the differentiation with respect to n, so there will be a log 2, you will get extra. Okay, now so now the degree of n has decreased by 1. So again if you look at, again this is of the form infinity by infinity. Therefore again we can uh, differentiate once. We get a limit, this limit is equal to limit n to infinity k into k minus 1 times n power k minus 2 divided by, again if I differentiate 2 power n, I get 2 power n. This log 2 remains log 2, I get one more log 2 for this differentiation. So if we keep going like this, what we get, we get this is equal to limit n tend to infinity uh, k into k minus 1, next time k minus 2. So up to at some point I'll get n square, then again I differentiate n square, I'll get 2 into n power 1 I'll get divided by that time how, so I'll get 2 power n times log 2. How many log 2 I get? So if there is k minus 2 here, I am getting log 2 square. Here I have this 1 equal to, here I have n power 1, that 1 equal to uh, outright. That 1, this power is 1. That 1 I want to write it as k minus k minus 1. So 1 can be, power 1 can be written as k minus 1. So if there is k minus 2, there are, so if the number is k minus 2, there are 2 log 2's are there. But this one is k minus k minus 1, though we get this in place of 2 we get k minus 1. So this power will be log 2 power k minus 1. Okay. So again we can differentiate this, because still this is of the form infinity by infinity. We get limit n tend to infinity. So this n, differentiation of n with respect to n is 1. So we get k into k minus 1, etc., etc. 3, 2, 1. And there is no n anymore. In the denominator we get 2 power n times log 2 whole power k. Okay, now in the numerator there is no n. Only in the denominator we are getting 2 power n. Therefore, limit n to infinity, this some constant by 2 power n goes to 0. Okay, so now this limit is 0, but we want to calculate. So whatever k, this limit is 0. Okay, that's what we have proved now. But we want to calculate this limit. Okay, so what we do, we split that limit. So p of n by 2 power n, that I write is first n constant term plus a1 n by 2 power n plus a2 n square by 2 power n plus a3 n cube by 2 power n plus a4 n power 4 by 2 power n plus a5 n5 by 2 power n. Okay, now by our so we have shown that n power k by 2 power n converges to 0. If this converges to 0, you put any scalar in before this alpha, any, you take any non-zero scalar alpha, uh, that will also goes to 0. Okay, there is no problem. So we can take any scalar, alpha can be 0 also, doesn't matter. So since this converges to 0, we see that each of these things individually goes to 0. Okay, then we can use arithmetic of limits. If an converges to l, bn converges to an converges to L1, Pn converges to L2, then the sequence An plus Bn converges to L1 plus L2. Okay, so by using this arithmetic of limits result, we see that this full sum, so this is converges to 0, this is converges to 0, so each of them converges to 0. So together we get limit n tend to infinity p of n by 2 power n equal to 0. Okay, but as I said, it is if it is a degree 5, we have if it is degree 5, we have 6 terms. If it is of bigger degree, say 100 degree, there will be 101 terms, but each of them going to 0, so doesn't matter. So in this problem, whatever degree they give here doesn't matter, the answer is 0, because the only idea is this when we keep uh, differentiating and apply L'Hospital rule, after a while, whatever power of this n power k, that k power will keep decreasing, and finally we will get a term with which is independent of n. So we'll end up with only the 2 power n in the denominator. That won't go anywhere. Since this 2 power n stays as it is, we get the answer is 0. Okay. Therefore, whatever is a polynomial of degree, limit n tends to infinity, p of n by 2 power n is always 0. Okay. So next time when you see a problem, just remember this exponential dominates polynomials, and just you can put the answer immediately is 0. But always remember why it works also, because for the exam you can just yeah, remember exponential dominates polynomials and put the answer. But in the interview you have to explain why the value is 0. Maybe you can use a L'Hospital rule, but many times interview panel they don't convince with the L'Hospital rule. So maybe you have to use and then some epsilon argument, epsilon n naught, the usual limit definition to prove that this is 0. That will be very interesting to do, proving that this is this n power k by 2 limit n tend to infinity n power k by 2 power n is 0 using the limit definition. So you take it as an exercise and you try to do it. Okay, so I hope you understand. And that this problem asked at least 2 3 times if I remember correctly. So please understand clearly. Okay, take care, guys. Bye.